Hello everyone, I'd like to welcome you to this video titled Writing Linear Equations, and you want to open up your math book to page 67, get out your math journal and a pencil. So you can see the two goals that we have here. First of all is to express the relationship between two quantities as a linear equation. So first of all, let's think about what is a linear equation. There we go. So if you turn to page 395 in your book, you can see the definition of a linear equation. So we can see it's an algebraic equation that has a dependent and independent variable. So we're going to talk about that. We even see some vocabulary words there, independent and dependent variable. The variables have no exponents and are not multiplied together. And the graph of a linear equation is a straight line. So we'll talk about when we graph linear equations, it'll make a straight line. So an example would be y equals x minus 15. All right, so that's a linear equation, just a basic definition. Now in this video, we're also going to be taking a look at independent and dependent variables. So first of all, an independent variable, you can see this on page 394 in your math book. This is a variable whose value determines the value of a related dependent variable. Okay, so we'll take a look at some of this, some examples of this here in the near future. So in the equation y equals x plus 10, for example, x would be the independent variable. And then also we're going to look at the dependent variable, 393. And so it's a variable whose values depends on the value of a related independent variable. So we'll talk about that. So in the equation y equals x plus 10, y is the dependent variable. So in order for y to increase, it needs something else to be added or changed within that equation. All right, now let's take a look at some examples of this. So writing a linear equation to express the relationship between two quantities here. So what we have here for page 67, it says Jacob is X years old now. Jenna is 10 years older than him now. If Jenna is Y years old, write an equation that relates to their ages. So we can see from the bar model, Jacob's age, right here, Jenna's age, so that's equal to Jacob's age plus another 10 years. So from the bar model, an expression for Jenna's age would be x equals 10 years. So now, since it is given that Jenna is already a certain amount of age, years old, we can write an equation relating the two expressions that represent her age. So y equals x plus 10. All right, now understand what these different parts mean. It's important to understand that, I should say. So the equation y equals x plus 10 is called a linear equation. Why is a linear equation? We have an independent variable and also a dependent variable. So we have x is called the independent variable. Okay, so x, that's Jenna's age. Y is called the dependent variable because the value of y depends on the value of x. All right, so we know that Jenna's age, again, is the same as Jacob's age, but 10 years older. All right, so we already know that Jen is going to be at least Jacob's age plus 10 there, so y equals x plus 10. All right, so writing y as an expression using x is called expressing y in terms of x. So let's say we plug in 5 for x, 5 plus 10 is 15. Let's say we plug in 10 for x, 10 plus 10 would equal 15. Whatever value you're plugging in for x, that means you need to add 10 to that. So that's an example of a linear equation and understanding the independent variable and also the dependent variable. Basically, the dependent variable depends on the independent variable in order for it to change values. So now let's take a look at some examples of this. So let's turn to page 69 in your math book. So it says write an equation for each situation, then state the independent and dependent variables for each equation. So number 2 on page 69, Ashley took P minutes to jog around a park. Sophia took 12 minutes longer to jog around the park. If Sophia took t minutes to jog around the park, express t in terms of p. So a couple things that we know about this. Ashley took a certain amount of minutes to jog around the park, p minutes. We know that Sophia took 12 minutes longer then. So if Sophia took t minutes in total, we need to figure out, express t in terms of p. So what this would look like, t, first of all, I want you to write this in your book, is going to equal, so the amount of time that Sophia took will equal the amount of minutes that Ashley took, p, plus 12. Okay, why is that? Because we know that Sophia took 12 minutes longer to jog around the park. So we need to think about what's the independent variable and then what's the dependent variable. So the independent variable, okay, so the variable that does not need anything else for it to change would be p. Okay, so p equals independent variable. Now the dependent variable is going to be t. Okay, in order for t to change, p will need to change as well. So if, let's say, we put 5 there, let's say it took Ashley 5 minutes plus 12 minutes, it would take Sophia 17 minutes. Okay, so t is going to change only dependent upon p changing. Okay, so t would be the dependent variable. Again, so p would not be changing because t changes. Okay, p changes, p will change, therefore it will eventually make t the variable that will change there. Okay, let's take a look at number 3 now. So it says a bouquet of roses costs $30. A bouquet of tulips costs $m less. If the cost of one bouquet of tulips is $n, express n in terms of m. So taking a look at this problem, we know that what we're trying to find, what we know are important questions to ask. We know a bouquet of roses costs $30. A bouquet of tulips costs $m less. So tulips, we know, are cheaper than roses. So now if the cost of one bouquet of tulips is $n, express n in terms of m. So we have n, one bouquet of tulips. That's going to equal 30. Where am I getting 30 from? That's how much a bouquet of roses costs, minus m. So now we got to figure out what the independent variable is and what the dependent variable is. Okay, so we can see the independent variable is going to be m. All right, because that's what we're going to subtract from 30 in order to get to our total cost here. So the independent variable is going to be m. So let's write that down. M equals independent variable. Why is that the independent variable? Okay, because this m is not going to change based upon what n is. We have to plug in the number for m first, and then that will tell us n. It's not like we plug in the number for n first, then we figure out m. All right, so we got to figure out what m is first, and that will change n. So therefore, the n is dependent. The answer I get for n is dependent upon what m is. So we're right. N equals the dependent variable. Now let's take a look at page 74, and what we're going to do is practice using tables and graphs to represent linear equations. Okay, if you remember before, a linear equation can be represented in a graph as a straight line, so we'll talk about this here in just a minute. So let's take a look at the problem number 1. So it says solve the width of a rectangular tank is 2 meters less than its width. So if the length is p meters and the width is q meters, write an equation to express q in terms of p. So what we're going to do, so we know width of the rectangular tank is 2 meters less than its length. So what we're going to do is Q, trying to find the width here, Q is going to equal P minus 2. Okay, and why is it P minus 2? Because we know the width of a rectangular tank is 2 meters less than its length. The length is Q meters. Sorry, P meters. The width is Q meters. All right, so that's why we have Q equals P minus 2. Dependent variable is going to be P. Sorry, independent variable is going to be P. Dependent variable is going to be Q. Why is that? Because Q will change based upon what you insert for P. All right, so let's take a look at a table and see how this would play out. So if the length is 3, width would be 2. Length is 3, width is 1, 2 less. Length is 2, length is 4, width is 2. Length is 5, the width would be 3. Length is 7, remember Q equals P minus 2. Okay, this would be P, minus 2 would be 5, giving you the Q. P, which would be 8, minus 2 would give you 6. So we can see the different variables here. So the independent, and this is the dependent variable. Okay, so once again, our linear equation is Q equals P minus 2. Okay, so we can see the length. The P is the independent variable. Q is the dependent variable. All right, so taking a look at this, we're just going to graph these ordered pairs right on our graph here. So our coordinate grid, so we can see 3, 1 with the ordered pair 3, 1. So length is 3, the width is going to be 1. So we'll plot our point just like this. Next one, 4, 2. Go over 4 and go up 2. Make sure you understand that you're aligning it with the length and width. So you can see the x-axis. X-axis is the dependent variable. Y-axis is the independent variable. And we go 5 and 3. Again, I'm just writing my ordered pairs here. 6.64, 6, and then 4. You notice I have the correct answers here because it's forming a straight line. If it were forming a line that was very jagged, looking like the Mississippi River, you're not going to have the correct numbers filled in with your linear equation there. So 7, 5, and then 8 and 6. So now once you have your points plotted in the coordinate grid, you want to just draw a straight line. You can do this with me. Okay, get that as straight as you can. Mine's a little crooked, that's all right. Just connecting your dots there. All right, and remember, whenever it's a straight line like this, you understand that you have the correct answer because it's following a pattern there. So that is how you graph a linear equation. All right, so that's using a graph to represent a linear equation, and we're going to conclude the video with this. So it concludes the video on writing linear equations. If you have any questions about writing linear equations, please come and see me.